Hello, everyone, and welcome to Agentic Coding for Scientists. This is the December 2025 edition. I think that this image here pretty well communicates where we're at. It says build with agent, and this is very exciting, but it also says AI responses may be inaccurate. But we are scientists, and we want our responses to be accurate. We want to build code that allows us to do rigorous scientific analysis. So that is the topic of today. How can we use these tools to do rigorous scientific analysis? My name is Eric Mattson. I'm a professor and Howard Hughes investigator at Fred Hutch Cancer Research Center. And I've been using Claude, I think, in a great way that allows us to do analysis in a rigorous way quickly. This is going to be a tour, basically, of this series of blog posts that I wrote. Here's the address, but it's also in the YouTube comment box. And so we'll go through some of this. There's more here than is here, than I'll be able to talk about today. And I have to give a little disclaimer, which is this is written from the perspective of someone who works with public data and writes open source software. So some of you might work with public health PHI data, and there will be maybe restrictions on what you do. I'm not going to address those really at all. Please go ahead and make comments and ask questions in the YouTube live comment box. But just know that if you post something there, it will distract me. So try to avoid just having chatter in there. Great. So we're going to be using this. And also, I'm going to be giving a tour based on this fake CompBio project that's also linked to. And you can, if you want to try out the things that I've done, you can use this template. So let's start from the beginning. What is a coding agent? So a coding agent is something, it's a computer program that works with a large language model. And what distinguishes it from using something like ChatGPT in the web interface is that this computer program can read your files, it can edit those files, and it can run commands on your behalf. So I will demo those. So here I'm going to be using Claude Code. So Claude Code is one of many different agentic coding tools. And Claude Code CLI is one that you run within the command line in the terminal. There are others. So there's one for Gemini, there's one for the OpenAI models, and there's also other solutions such as Cursor, which is an IDE that has a lot of these sorts of things really baked in. I'm just going to talk about Claude because it's what I know, and the principles that I'm going to be talking about are the same no matter what tool you use. So what I'm going to do is I have this repo, and it has a test. This test makes sure that it checks to make it's able to detect when you have sequences that are at different lengths. And I'm going to break this test. So I've broken this test now. And as a demo of the sorts of things one could do with Claude Code, you can say run make test and fix any broken tests. So let me emphasize that this is a computer program that is running on my local machine, but it is constantly making these queries to the large language model, in this case housed at Anthropic. So it has run the test, and it can see that there's a failing test. It diagnoses the issue, and it makes a recommendation about how we're going to change things. So it doesn't directly change things right away. It makes a suggestion about whether about how we can fix this test. Here it says we can trim this back to exactly the way it originally was. I can say yes, and actually I'm going to say yes and allow all edits during the session. So I prefer to be able to let the coding agent run. So now it has succeeded in fixing the tests. So that's a little demo. And I'm going to go into a little bit about the features of Claude Code. So Claude Code, this thing is free to install, but you need a paid plan in order to use it. So although it is just a terminal program, it is a very, very fancy one, and there's lots of things one can do. So here's one thing you can do. You can put it in bash mode, and you can do something like touch. I can touch a file which makes a new file. And you might ask, well, I already have a terminal over here. Like, this is me in the terminal, and I could have just touched it there. But if I made a file over here in that terminal, Claude Code wouldn't know about it. So now that I've run this through the bash mode, it knows that joke.txt exists. So I can say, let's fill a joke with a joke. And while it's running, I can actually hit escape and interrupt it. And if I said, OK, I don't want to do exactly that, I want to say, fill it with a funny programming joke. So I edited that prompt after stopping it. So sometimes you'll be watching what the agent is doing and say, whoa, that went off the rails. I want to do something else. So let's open joke.txt. OK, why do programmers prefer dark mode? Because light attracts bugs. You can decide whether you think that's a funny joke or not. So now I can say something else like, let's replace that with a Star Wars themed program joke. So now it's going to add a Star Wars. OK, why did Anakin Skywalker fail his code review? Because his commits were always to the dark side. Good. OK, so I'm going to show one other feature here, which is, so we can look at joke.txt. It has that new joke. We can hit escape twice, and we can go back to the state before it changed that. And this is a really neat feature, because sometimes things go off the rails. You want to rewind the state. So this is an interesting menu. So one is you can just restore the conversation as it was, but leave joke.txt with the Anakin Skywalker joke. Or you can rewind all the way back to exactly where it was before that was done. So here we can go back and see, OK, now it's gone back to the light attracts bugs joke. So so now an elephant let's see what this brings up. And so, like I say, I like to let it edit my files directly, but I like to also be able to see the changes that it's making. And I do so using the Git interface in VS Code. OK, why do elephants make terrible programs? Because they're afraid of mice and they can never forget to free their memory. These are good. OK, so there's another thing I want to describe, which is you can hit double Control D to exit. But maybe, I mean, this happens often. Maybe something happens. You need to get back in that conversation. You can say Claude and then resume. And it will give you a list of different things that you could go back to. And so now we're back in, and we can continue as we were before. Hopefully that's clear. So there is a Vim mode. I have Vim mode. I love it. I'm not using it right here in this particular demo. Right, you can also send a message while Claude is working, and that will sort of guide it as it is doing things. There's quite a lot of options in config, and we'll come to some of these things. But it's worth taking a look at those. So now we're going to step back a little bit and think a little bit about what this computer program is doing. Not my computer program, but what is Claude actually doing? And I think it's very helpful to look at this thing called the context. So context is it shows you when you run this / command, It shows you what is in the context. So what is the context? So in order to describe this, I need to describe what is Claude actually doing. So let's say we make a request to Claude that says something little like, let's change this function so it returns none. So what happens is that request goes to this computer program. It gets wrapped up in a lot of things I could just call a packet. And that gets shipped over, that complete conversation gets shipped over to Anthropic. And I think the first conceptual approximation, it does not consider any state about my project. It looks at that whole packet of information and then comes back with a response. That response says something like, okay, go ahead and make an edit to this file at this line, and then edits the file. Or it runs the thing. So I think it's interesting and very useful to think about what is in this sort of packet of information. So the first thing is there's the system prompt. And the system prompt is things like, you are a helpful coding agent. These are the sorts of things that you can do and you shouldn't do. I can say from personal experience that this says things like, don't generate new influenza sequences or something like that. It also has these things like MCPs. So I'm not going to really go into MCPs today, but an MCP that's short for Model Context Protocol. I imagine it as being that thing when you go to the dentist and they have that universal arm that you can attach the drill onto and the little polishy thing and all the other tools. It's an interface that allows you to attach things to the agent so that it can do stuff. That's MCP. So it needs to use some of the context in order to describe what are the MCPs that are available. Custom agents is the next thing. And here we'll talk a little bit later about custom agents, but we have 2 custom agents that I've defined in this fake comp bio project. Memory files. So memory files are quite important. We'll talk about those more, but here's an example of a memory file. This is claude.md. It describes how you want the code to be written and sort of gives you context about what the project's about. There's also messages. So these are the messages that we've used so far in this session. So, and this is the key thing. So if you have a very long discussion with Claude about things and you're following up, you're continuing, these purple ones are going to start occupying more and more and more and more and more and more space. And it can't go on like that. So this has a finite context. So it has 200,000 tokens. And so once that 200,000 token context is used up, it can't go on. And so it does have an auto-compact feature where it tries to keep track of what you wanted to do. And then when you run out of context, it basically starts a new session, but with a summary of what you've learned. It's trying to just remember the important things. I personally have actually turned that off, and I prefer to turn it off. But if you want to turn it on, because I like to, config. So I could toggle things where I could do auto-compact equals true. And you can see that now it's occupying some of the context with this auto-compact buffer. So it's reserving this bit to remember things that it wants to know if you need to auto-compact. But I really prefer to try to keep my context very clean. So I'll turn that back off. So that's a little bit of information about context. Again, I want to remind you that this is like the short-term memory. And my personal experience and the experience of people you can read about, there's performance goes down when your context window goes up. And it's just, you can imagine it like a human. If you're trying to remember 15 different things, it's much more difficult to make a reasoned decision than if you only have to remember 2 or 3 things. So I'm always trying to think about what are the strategies I can use to keep that context as clean as possible. So Claude only allows 200,000 tokens. Gemini allows 1 million tokens. That might be great for some situations, but I find that even when the context gets full with these 200,000 tokens, performance for me tends to go down. So let's see. So yes, I am sort of obsessed about how much context I've used, and I have replaced the default status line with this custom status line. This tells me what the directory I'm in, what the branch I'm on, and what the context is being used. And this is auto update failing because I'm in a development container, which we can talk about later. But let's move on, and we'll come back to some of these things a little bit later. What I've talked about so far is really about how to use this in the small. Like, what are the day-to-day, how do you actually get this thing going? But I think I would also like to talk about how do we use it in the large? What are the processes that we can use to get good performance out of this? So I'll start by cleaning up, deleting that joke.txt. Okay, now we are good and clean. Didn't I just say clear? Okay. So let's see. So how do we use this? And in my mind, the strategies that you need to use to get good performance out of an agent is the same. Those are the same strategies you need to guide a research group. So in my mind, when you are guiding a research group, you need two things. You need to tell them what is it that you are wanting to do, or work with them about figuring out what is the plan. You need to make the plan. You need to decide on your standards for what that plan is. So we are going to move through this. I've actually just recently added this design document. This is part of the Agentic Git Flow. And so we're going to walk through this a little bit. So the first thing that we're going to talk about is a design document, and we're going to come up with an issue file based on that design document and the existing code base. So my first prompt is going to be something like take a look at overview. So this overview, and I'll just say, and a markdown file that describes detail the next minimal but non-trivial step in implementation. Okay, so I'll let that cook. So what is this overview file? This overview file describes what it is that we want. And so just a tiny bit of context here. So this is a fake comp bio program that is doing UPGMA, and it is currently hardwired to just use the Hamming distance, but we want it to be able to swap out distances. So we want to be able to include Hamming distances, but also Levenstein distance. So the first step I hope it's going to do is do a refactoring step that allows us to be more flexible in terms of what distance functions we put in. So what it's doing is it has read our overview document and it's planning things. So these planning documents, okay, oops, shoot. I pressed escape just out of habit because I'm a Vim person. Oops. And it interpreted that as being I don't like those changes. So I will actually use Shift Tab, and I will move to the accept edits on mode. Oops, sorry. Oh yeah. No. Let's see. So did it make a markdown document? I'm paying. I'm paying the price for having a for hitting that stray escape. So these planning documents in this case are not that complicated. It's a single markdown document. You can also use tech. They can also get quite elaborate. So this is our flagship project right now. And it's there's a whole series of Markdown documents that are basically built into this big wiki, which is rendered by MakeDocs. And this goes on and on about how we plan on implementing the next version of our software. So this is a project that has been going on for a long time. And just writing those planning documents took months. And so I think that that's sort of an interesting statement, that we are in the world now where the key piece, and it's certainly not the only piece, but a really important key piece are these overall planning documents, and that we get to code by just thinking. Okay, so it has come up with this thing. And we're going to read this, and I encourage you to read this, but I also encourage you to have the agent read it. So now we've cleared the context, and I'm just going to say, please read step 1, and is this the simplest way to proceed? Review with Clean Code Reviewer. So what is this document? It's going to describe the next step that we have. So let's just look at it using the VS Code renderer for Markdown. So it says, first, we're supposed to extract the compute distance matrix function. Here's the current state, and we want to be able to extract out the distance matrix so that we can plug in different types of distance matrices. So it's describing what are our, how this is going to go, and this is quite nice and detailed. And why is it important to use this planning document rather than just start editing the code right away? Well, this is a self-contained thing, and one can much more easily load this whole thing into context and, for instance, get a review of that thing. So, which is what we've been doing over in this other tab. Actually, I don't have my favorite mouse. So, what's this? Okay. So it is looking over, like the Clean Code Reviewer is looking it over, and I will take a question here. When you say that messages information can use up context tokens, is that referring to one session within Claude Code or all possible sessions? I.e., will it stop responding after tokens are used up? Great question. So I'm talking about that one context window that we looked at using context. So that's within one coding session. We can also so you can also look. So there is also usage. So there's like, I'm on the Claude Max plan, and there's limits for how much you can use per day, or like per session, not per session, so per week, and they call this current session, but like until 10, I have this many tokens in total to use with Claude Code. So, and this is how far I am in the week. So I don't know exactly how many tokens this is total, but it's, I've been doing some coding this week. Hopefully that answers the question. Okay, so we've had a review from the reviewer, and it says, okay, zip silently truncates unequal length sequences instead of failing fast. So, so let's like, please edit the MD file accordingly. This is a good recommendation. So it can now edit this design document. And I don't want to give the idea that we're just querying the models to like do things. I think there's a very important step of looking through this file carefully, because sometimes it won't do what you wanted it to. It won't do it how you wanted it to do. So you really want to be paying close attention to this file. I think maybe I will talk a tiny bit about the clean code reviewer. So one of the reasons why it brought this up is in clean code reviewer, I have something, this line here. So let me back up. Okay. When I did that at clean code reviewer, it invoked what's called a subagent. And a subagent is like a mini version of the Claude program that is run within Claude. And one thing that's cool about that is that subagent has its own context. So even if it does lots of things, it makes lots of, it reads lots of files, it doesn't pollute your main context, it just goes away, it comes back and it makes a summary to the main Claude instance. So that clean code reviewer also has special instructions. It's different than the anti-pattern scanner, which is a different agent that I have. So the clean code reviewer is described just by this file. It's just a markdown file. And it describes, it starts by saying, you're a distinguished software engineering expert. But it describes the things that I really care about, what I care about in terms of clean code. And this is an important thing. And this is different than, I think, a lot of what's going on in typical software engineering. If you're writing a web server, you want it to be able to take any weird input and be happy. So for me, if I'm writing a pipeline and something is not as I expected, I want the whole thing to come to a screeching halt with a really good error message. So I want things to stop if things are going sideways. So that's why this clean code reviewer flagged that this was not a fail fast thing. So it made sure that the design included something fail fast that would do something intelligent when the sequences were of different length. So great. So now let's say I have read this. I'm happy with this idea of how we're going to do the next step. So my personal next step is going over here, is to raise this as an issue. And you can have the agent raise it. You could copy and paste it into GitHub. That would be totally fine. But please post as an issue using GH issue, create body file, like at step. I could have practically done that. So what is GH? GH is a command line tool that allows you to interact with GitHub. And I know not everybody uses GitHub. Some use GitLab, but there's an equivalent CLI for command line interface for GitLab. I haven't used it, but it's out there. So now we can look at this proposed code change as an issue. And the next step is that your team takes a look at this issue. So I will invoke somebody else from my team and say, hey, can you take a look at this issue? What do you think about this change to the code? So, and they'll take a look over, maybe they'll make comments, and then we can revise this plan. And this becomes the plan for the next step. So you can see, okay, I've used 21% of my context. Of course, I want that to be as low as possible. This is not that much for this particular issue. This is a tiny little issue. But oftentimes, after iterating on something, I'll be totally running out of context. And so it's time to start fresh. So I will just start, I will say clear. So that clears the context. Let's just look at it just for fun. Here we are, we have a totally clean context. So now I invoke a special prompt. And so this prompt looks like this. So I will first paste it with an edited, so it's issue 1. And I want a feature branch. So let me just get this going, and then we'll read it. So this says, read the issue. We're going to do the work that's described there. Think hard to brainstorm clarifying questions. So you really want, like, we're going to move into implementation now. If you have any such questions, stop and ask them. Once everything is clear, make sure we've pulled main so that we have an up-to-date main branch, and then make a new feature branch to get to work. And don't get creative with the implementation. Copy the code directly from the issue as a starting point. You can tell I've run into issues with these sorts of things. Refine code is needed, but stop if you start deviating from the issue significantly so that we can discuss. If everything is going well, please continue until the issue is done and all tests pass. So that is a nice long prompt, and it has come back with a clarifying question. So exporting for no. Let's not I don't like that anyway. Export any of the functions. Thanks. So it's pulling origin main, and then now it's making a new branch that shows where we are, and it's going to start implementing. So I can actually delete this file because it's a GitHub issue, and I don't want to commit it. So we'll let that churn along. I want to describe a couple of other things. So within this comp.bio project, let's look at the Claude directory. So in Claude, first I'll talk about the status line. So this is where that custom status line is. And you can see it's doing things where it's figuring out what the number of tokens are. And so if you're interested in using that status line, you can just go and grab this from this public repository and put it in, and you'll have that nice status line. Another thing is, of course, this was a very long, tedious thing. And so, of course, coders don't like long, tedious things. And so you can take this prompt and turn it into something called a slash command. So that's here. And we have a work issue, and you'll recognize a lot of what's going on here. And so this slash command says read issue, and it has a placeholder, which is an argument. So this is going to say, remember I had to edit it directly to say issue 1 and branch 1 dash ... But this is an automatic way of doing this. So we can go over to our Claude session and say work issue. And I'm not going to start it here, of course, but that would be the idea. I would be able to say work issue and then 1. And if I did that, it would start working on the same issue, which would be terrible because it's already working on an issue. Okay. So let's see how it's doing here. It has extracted the compute distance matrix function. It's made these changes. It has done things, and would you like me to commit these changes? So at this stage, I like to look at what is going on and compare this with sort of what I imagine. So this is another opportunity that you have to check and make sure the code is as you like. I'm not going to check this in detail now, but let's assume that this is in good shape. And remember, if there's anything that you do like, you can stage it or commit it. And if there's things you don't like, then you can either ask the agent to redo it, or you can stage the things you like, reset with Git to the things you don't like, and then start with a new agent. But I'm just going to say, let's stage, commit, and push, and make a PR. But again, this is another opportunity you have to make sure the code is as you wish it to be. So here we are so we have created the issue, and then once everybody likes the issue, we're going to iterate. So if I didn't, I would, sometimes you commit on a topic branch stuff you don't like, and you continue to work on it and iterate it on it. So it has created a PR. So this is a pull request, and I can look at this, and other people on my team can look at this, and I can say, okay, I like this. I can make a comment, and I can even. So let's just see. I don't know. What comment should we make here? I mean, I guess it's got to be sort of a silly one. Let's see. Let's say a little more detail. It's already pretty detailed, but let's see. So I'm going to submit a review and make a comment. I don't know why I'm not allowed to. Okay, so I'm going to make a comment. So please read the PR review on the PR and make a plan. So it is looking through things, the PR review comments, and it's deciding what it's going to do. So of course, this is a bit silly. I already looked at this code, and it was fine, but oftentimes it's not fine, so you can make comments, and other people in your team can make comments. So that's, so we can say, sure, and then it's going to expand this even farther. It's double checking that the tests work, which of course they do because this didn't really change things. Okay, so we also then have another PR review step. So that's before or after the humans are reviewing things, we want the agents to review them too. So please review PR2 as per Claude MD. And so this Claude MD I haven't talked about a whole lot, but it includes the things like our coding standards. And there's some really important stuff in here. So if you have worked with these sorts of tools, you can attest that oftentimes they will try to fake tests. And there's a whole industry of like mocking things, but I hate that for scientific work. We can use small data sets within our repository to come up with real tests. And so it's going to check to make sure that the tests are real. And it's so important that not only do we have that sort of thing, we also have this critical anti-fake test barrier in all caps with emojis. And this stuff is actually important. So you want, and so this was written with the language model. I mean, I did not type out this emoji myself, but when I have been learning about how these language models work, this stuff really is actually important. You want to use emphasis and all caps and emojis to make sure that the things that are really important are visible to the model. And this is a really important thing. The temptation to fake is a design smell. Address the underlying issue rather than masking it with fake implementations. Also, this is something, again, the coding agents typically want to make things so that they absorb errors, but I don't want that. I want it to fail immediately with an error message. And again, here are the clean code principles. Simplify relentlessly. Those of you who have used these agents know that also sometimes the code gets really bloated. And I really emphasize simplicity. But here is the final important thing I want to emphasize, which is this pre-PR quality checklist. So that's actually explicitly what I was referring to here. So it says, please review PR2 as per Claude MD. It knows when it reads this that it's going to do the pre-PR quality checklist. And the first thing is it makes sure that we have consistent code formatting, documentation is up to date, and type hints. So type hints are a way that you can use static types within Python, which is a duck type language. And those are very helpful for ensuring reproducibility and correctness. So another step is it runs a clean code review. It checks the tests again. It makes sure that everything is built fast. It checks for naming conventions and so on and so forth. So it is doing all these things. And so another thing it says is that it needs to make sure that you've actually done the thing that was in the issue. So it is checked to make sure all the tests pass. Everything looks good. It has excellent separation concerns. That's something I care about. A fail-fast implementation. Okay, and it has some improvements. So we can just say, let's fix all the issues now. Saying, well, you could merge it as is, but here it has some suggestions about better naming. I mean, I think this may be debatable whether these are improvements, but in any case, it's going ahead and fixing all of these things. So that is the life cycle, pretty much. And then so we can go back over here and look at our pull request. And when it pushes, we're going to see a little update. So let's see. What are some other things I can talk about? Oh, yeah. Okay, it's going to commit and push. And this is the iterate with the robot and the human. And then, yeah, I would certainly invoke the rest of my team for approval. So I'm not demoing that, but we just got robot approval, the agent deciding that our code was OK. So now I have to refresh because it's updated the code. And I like this code now. I would look at it for real. And then I like to squash and merge to have a single nice clean commit that describes what's happened. So I'm going to squash and merge that. OK. So one thing that I think is interesting is it does, if you look at the commit messages, they co-credit Claude as being a co-author, which it certainly is. And so now we have completed this issue lifecycle. And so that's a perspective on how to use agents in a Git flow, which I think leads to good, high quality, clean code that does what you want. We've had a lot of opportunities to make sure the code is as we wish. So I'm going to talk about some other things, but if you have any questions, please go ahead and type them in. So one thing that I think comes up that is important is security. So I have done this in what's called a dev container. A dev container is a little Docker container that is specifically designed to work with VS Code and other coding tools. So you can read about that there's this dev container.json. So it describes things like what are the things I want to mount in my local environment and move here. It also does this thing. It uses a SSH auth sock, which is an authorization socket that allows it to use SSH. So it's using the GH tool, using my SSH keys, but it can't see my SSH keys. So if we ls SSH, it only has the known hosts. It does not show my SSH keys. So the agent never actually sees my SSH keys. So it can't do something like post those SSH keys on Twitter or some other thing, which I would not want. And I think also this dev container setup allows you to only mount the directories that are important for that agent to be able to use. So maybe you have some part of your home directory that you want the agent to be able to see and other parts you don't, then you can implement that using these dev container things. Is it some complete total failsafe? No, probably not. I don't know a whole lot about security, but it's definitely better than just running Claude, being able to do all sorts of things locally. And I think we need to think in the long run about being able to set things up in a sandbox type environment, because whatever we're thinking that the models are doing now, we're going to want them to be able to do a lot more moving forward. So we need to be able to set things up so that they are free to do all the things we want them to be able to do within an environment that doesn't damage everything else. There are lots of other things in the wiki, but there's a couple things I want to talk about that has to do with doing science. And I'm not, so some of these I've sort of covered. Oh, yeah, here's another thing. Backwards compatibility is not a thing. I mean, oftentimes we're developing things and the agents want to be very careful to not perturb the existing API. But that's okay, because it's pretty much a customer base of one when we're doing research. And so in order to avoid lots of crufty old code, we try to encourage breaking changes. So pipelines. So oftentimes we'll be writing code that is for processing data, and it's not sort of a new model or something, but it's really important too, and you want that to be correct. I use the system now where I have several steps. So the first is I read the paper that has the data. I identify what one might call invariants for that data. So it might be, here's the number of sequences I expect. Here's how mutated I expect them to be. And I sort of make, in my issue description, I describe, like, these are the things that I expect to have. And then I write agentically a little parser that is very, very inefficient and only processes a tiny fraction of the data, but it's something that I can check line by line by line by line and make it 100% sure that this is doing exactly what I want. And then I commit that and sort of set that aside. And then finally, I let the agent come up with the pipeline. It is guided by these invariants and by this little test case that allow it to have a target. And then, of course, I read that code as well. But it's really, really nice to have some guidelines so that when it comes up with wrong code, it can see that and it can fix things on its own. And then the last is, once the data is processed, I like to make these interactive visualizations. And it's so easy to do these things now. So here's just a little visualization I came up with for a data set. And this is just Altair. And I mean, there's literally less than an hour to come up with this interactive visualization. It allowed me to come up with, to find bugs. And actually a colleague, Hugh in my group, this point used to be down here. And he was like, that's wrong. And we would have never caught that without having a visualization. And again, this is not a visualization of the results. This is, we're just bringing the data from some other remote source and bringing it in and onboarding it so that our models can be fit to it. So that's another thing I'd like to have. So one thing that scientists use a lot are notebooks. Claude Code can do notebooks. It does it pretty well. It's not amazing. I would say that it's good at editing code within a cell, but if you want to do something like, let's reorganize this, it gets a little bit confused about where the boundaries of the cells are. So that, I think, is pretty much what I wanted to say about doing science. The last thing is this. I mean, I think I care a lot about flow state, and it's an adjustment. But when I'm thinking hard about planning things, that sort of issue creation thing, I just stay present with the agent and I'm watching it and suggesting edits and thinking while it's thinking. I talk a little bit about the emotional experience I've worked with an agent, but this is someplace I want to hover, which is that it is really fun to brainstorm with an LLM. And it does have a lot of broad experience, and it can give you reasonable guidance. They're also sycophantic. They will also tell you have a great idea when your idea is not. And I don't think that I can do any better job than to show this video of Travis Kalanick talking about doing physics with AI. And I hope that this
GPT or Grok, and I'll start to get to the edge of what's known in quantum physics. And then I'm doing the equivalent of vibe coding, except it's vibe physics. And we're approaching what's known, and I'm trying to poke and see if there's breakthroughs to be had. And I've gotten pretty damn close to some interesting breakthroughs just doing that.
So I'm not a quantum physicist, but I venture to think that like Travis Kalanick has not come up with any great breakthroughs doing this. But he's being misled by a large language model that wants to make him feel good. And I do think that they have, these language models have high specificity but low precision. So if you write out a file of your new quantum physics idea or your new research idea, and then you come in with another agent, you say like, critique this idea, poke this idea full of holes, it will probably do a reasonable job of poking that idea full of holes. So that can be a workflow that you can use if you sort of feel like you're going out on a limb. But of course, the whole thing here is that these models are not here to think for you. They can, they have a lot of experience. They can bring a lot of ideas to the table, but there's no substitute for thinking and carefully considering an idea before you go down a certain path. I am sort of wrapping up, but there's some important things to say. I think it's really important to think about how this leads, where this puts us as far as scientific training is concerned. I think there's actually some really nice things that it can do for trainees, but it's a complicated picture. There's a lot of really big ethical issues about AI, and I don't want to be in the position of being an AI booster, that I'm saying that this is an unqualified good thing. I think that this is sort of like nuclear technology. It is amazing. It is a remarkable advance, and it has a huge potential for humanity. I think that there's also huge possibilities for really bad things happening. I mean, I worry a lot about climate change, but I don't think that climate change is going to kill us in the next 50 years. I think it's totally possible that AI is going to kill us in the next 50 years. I think a lot of people think that. And that's a really profound statement. And when we think about in history, scientists have had a huge influence on how nuclear power was developed and on safeguards for nuclear weapons. And I really think it's our responsibility to start thinking about how can we contribute to the conversation around responsible AI. So I haven't seen any other questions. I guess I will wrap up there. I had a lot of fun doing this. I hope you have a lot of fun working with it. You can always drop me a line or another comment if you want to have more conversation. So, here's Cecile. Okay, Cecile asked, are there some coding projects for which you would not use Claude or some other agent for some reason? Nope. This is the way I code now. And I code using issues and ideas, and I cannot think of a reason I would not use a coding agent. I can say that I am sort of in a sweet spot for using coding agents. I write Python, and I write machine learning-y sort of code. Like I use PyTorch as sort of like my go-to tool. I know that I haven't done any R for a while. I know that when I last tried doing R, it was not great. It wrote some pretty terrible R. So all the models are getting better very quickly. I wasn't trying it using this sort of interface, but it's possible that it's not a great win when you're using R. But for Python, using PyTorch, it is great. Okay. Well, thanks everyone. I appreciated the questions. Thanks for your attention, and get in touch if you want to chat. Oh, one more. Oh, it's Dirk Peterson. Dirk used to run SciComp. Okay. So do you have any thoughts on using less powerful models such as Haiku and Sonnet especially Sonnet with a larger token. So this is great. Dirk knows a lot more than I do. I have not tried playing around with the models. So apparently you can use Sonnet 1M with a larger token window. I think that's great. I think one of the things that is really great about having a larger token window is that you can do a lot of research in a code base. So if I had we don't have an enormous code base, I can imagine running out of tokens effectively if I had a very large code base and needing something, but maybe the Sonnet model isn't not quite as good at reasoning. So yeah, that sounds interesting. I also know people that have done something where they use Gemini as a tool within Claude Code, and they ask things like, Gemini, go off and do some research in this code base and come up with a plan to do X. But it's sort of a little bit it's mostly the research phase. And then it comes back with a report. And then the core model can do something with fewer tokens because it has the report that sort of gives it an index. I guess I tend to, as our code base has gotten bigger, I do have sort of directories so that, not folders, but I have basically descriptions that give the model an index and is saying well, this part of this code, this concept is implemented in this part of the code base and so on and so forth. So I think it mitigates some of the need for that, but that's cool. Okay. So what do people in your group say about it? Well, I would say that people's experience is varied. I have been trying to get people to use this style of coding. As all PIs know, just because you think that something is a good idea and you propose it as a good idea does not mean that everybody follows you in that path, which is as it should be. So I think, people complain about the sorts of things that one can imagine that you would complain about, like it making terrible bloated code or it going off the rails. Again, I feel like if you are making these minimal changes and you are carefully inspecting its plan and so on and so forth, it minimizes the effect of these bad outcomes. But yeah, I would say people's experience have been mixed. I mean, for some people, the projects that I'm working on the closest, it's moving really quickly and I think really well. We have a beautiful code base that has grown a lot in the last few months. So sometimes it works really, really well. I think when you use these sorts of strategies to manage your context and to keep it on track. Dirk says, excellent. I learned many more things, even though I just used Claude Code for a year. Oh, thanks, Dirk. Okay, I mentioned interactive plots, but I'm curious how much you've used Agent to explore a data set as opposed to coding. Excellent idea. I totally have not used agents to explore a data set, but that would be an interesting approach. Thanks for the idea, Chaim. I guess I'm typically using it to write programs. Even if I'm exploring a data set, I use it to write a program to explore the data set, which maybe is the same thing, maybe not. But the interactive plot is a little bit more towards that direction. Okay, well, I guess we'll wrap now. Thank you very much, everyone. And maybe, I termed this the December 2025 version. Maybe I'll do another one in December 2026, and who knows what the agents will be able to do then. All right, thank you. Until then.